So during my free time, I usually love to walk around and take photos. So please, could you introduce yourself?
I'm pursuing a computer engineering, interested in ML.
Oh, sorry, I don't hear you somehow. Okay. We have Abdullah joined as well. Okay, so this is the first machine learning study jam today. And we had already got some introduction to machine learning during our info session. And because we have different students now, and this is the first time you are the first time we are starting to learn machine learning, I would like to start from basics. First of all, I would like to go through the prerequisites. I will share this website later on. So for our prerequisites, we need to have some good knowledge of algebra. And this is the topics listed here that if you don't know, you should study by your own, or you should just look through and refresh your knowledge. Some knowledge on trigonometry, statistics, calculus, Python programming, and some basic terminal handling. And if you are not good at Python programming, we have study jams on Python fundamentals on Monday, each Monday at 5 p.m. Japan Standard Time. And the rest, like algebra, you can, I think, study by yourself. And because this is the first lesson, I would like to start from the basics to understand the machine learning problem framing. And let me just share this website with you. I think it is familiar for some of you because I used the material for our first session, info session. So the goal of today's study jam is to learn about machine learning problem framing and common machine learning problems. Then after you learn this, you can check yourself here by answering some questions. Try it yourself, 2 questions, and check understanding by completing the quiz. And if you have any questions, you can ask me anytime, and we can go through these questions together. Okay? Is it clear?
Yep.
Great. So estimated length is just 1 hour. I think it's enough for our lesson today to get some overview of machine learning, the problems framing, the mindset, and what's the good problem, what's the bad problem, and to check our understanding. So you can start.
Sorry, I got disconnected.
Okay, that's okay.
Should we do something now?
Oh yeah, if you didn't understand, then let me.
Yeah, I got disconnected in between. So
Okay, um, so we are starting the machine learning crash course, and as a prerequisite, like an introduction, you should complete the introduction to machine learning problems framing, this 1 hour material. And if you were present during our info session, we already covered most of the material that time.
right.
But for the first session, I think it's good to refresh the knowledge and check yourself by answering questions in Try It Yourself and check your understanding.
Okay.
Oh, hello, Ajar. I just noticed that you joined us. Thank you for joining. So this is the first session on machine learning, and as a prerequisite, it's good to know the machine learning problem framing. So we started this study jam with this resource. I will put the link again in the chat if you don't see it. So our goal is to read the material with the estimated length of 1 hour. So we have a little bit less now. And oh, Tomoki, hello. Thank you for joining.
Hello.
So I just explained again what we're doing. So I just put the link into the chat. And this is the machine learning problem framing material. If you were present during our info session, I think Tomoki were present, then most of the material is familiar to you. but it's good to refresh the knowledge. And there are some exercises. Try it yourself here and check your understanding, which makes you to think about the problems that you may want to solve by machine learning. And it also checks your understanding of the whole material that you covered today. And when you are ready to answer these questions, let's discuss them together. Okay?
Okay, thank you.
Great. Thank you. And if anyone has any question, please don't hesitate to ask, or if you want to discuss something. By the way, it's better for you to log in with your personal Gmail account into the website to save the progress.
Thank you.
Okay, let's do it. Okay. Did you finish reading? Okay, let me see. Did you finish reading the overview part? This too? If you finish, please put the thumb up in your like emoji. Okay, good. Good. Okay. Okay. When you finish the common machine learning problems, let's just discuss together, or if anyone like wants to discuss these questions about 3 examples of using machine learning, like in the smart apply, YouTube watch next, and cucumber sorting. Like if Harsha or Neha wants to share the answers to these questions, and then we can proceed with this block of material.
I think it's better if all finishes and we discuss together and go.
Okay, and let's wait. And you can start the second block then.
Yep, I'm doing.
Ajar is finished. Okay, good. Ajar, did you finish?
Um, can you hear me?
Yes.
Oh yeah, just very quick overview and yeah,
Oh, that's good.
thank you.
I think it's better for us to discuss the first bulk of material, because if someone didn't finish, then we would just say or explain to the person what was the main thing about the first bulk, right? And then after this study session, the person can study it himself or herself. For example, the first bulk of material covers the what are the types of machine learning are, and lists common ML problems. Yes, and then there is there are three three examples here, and the questions are about these three examples. Yes, so I think reading this for now can be a little bit time consuming, and we have different people joined at different times, so it's difficult to work together. So I think if anyone wants to answer this question, for example, the first question, then we all will learn about this in a quicker way, yeah, without watching the YouTube, without reading these two materials. Any volunteer to answer the first question? Like, what user problem did these systems solve? So what user problem was in Smart Reply, YouTube Watch Next, and Cucumber Sorting? Any volunteer?
I can start with email.
Okay, can you please talk a little bit louder?
Sorry, can you hear me better?
Yeah, okay.
Yeah, so just in everyday life example, Smart Reply via Gmail is very helpful, because you are sure that the person who you are emailing to received your email. So for example, it's flight company or manager of the program. Yeah, that's very, so it's automatic. Yeah, it's generated by a machine. And as it was said, by natural language understanding. Yeah, but it's just like a pattern given how to reply for every email. Yeah, and for example, in case if the person is absent, to whom we should refer in the absence of a person.
Yeah, cool.
Yeah. And the same works for YouTube Watch Next. Like, we all watch YouTube, and we already noticed that the videos we watch, they are arranged in a way which we selected like most. So
yeah.
thank you.
And how about the cucumber sorting? Anyone wants to add something? This is the story about a Japanese farmer.
I guess that for cucumber sorting, the sorting process was predicted based on the size differences of the cucumbers, and a particular pattern, or a line drawn between which are smalls and which are larger ones. And with that knowledge, whatever the harvesting happens in the subsequent years, they can be sorted out easily based on what previously it was predicted.
Yeah. So if we compare these three examples, we see that machine learning is helpful when we want to achieve a quick result. Yeah. For example, when we receive an email, they say that sometimes we are maybe we don't have time, or it's not convenient for us to type the whole answer, and it would be cool and easier and quicker if we had some preset messages that we can just tap 2 times and then it's done. Yeah. And for example, for cucumber sorting, maybe the manual sorting takes time, and it would be more productive to have some program that sorts it automatically according to some features like size, shape, color. Yeah. And what the output from these systems look like. So for Smart Reply, it's a message. Yes. For the YouTube it's a suggested video. And for cucumber sorting is the different clusters of cucumbers. And the data source for these three examples, what do you think? What data was used to train the model to achieve the result?
I think for the smart reply, it's language,
Mhm.
yeah, the words, and for YouTube Watch, the number of clicks maybe.
Or the
Yeah, and
number of minutes you
yeah,
watch a video. Yeah, that's
and
cool. Okay. Yeah. Okay, then let's go to the next block of material. And if you're interested to learn more about these three examples, then after this session, you can dive in to know more, to read more about this use of ML. I think about 10 minutes to quickly see through this material will be enough.
Shall we start with ML mindset?
Yeah, like this, the next block of knowledge.
Okay.
I just already read it before. And I think the second block of knowledge is the purpose of this material is to show you um, the scientific mindset of machine learning. Do you understand what I mean? Like, I think most of you are from the research field, or you had some experience in research. And when we want to do some experiments, when we want to learn something, we set the goal, we do a hypothesis, we set the hypothesis, collect data, then test our hypothesis through experiments, analyze the results, draw some conclusions, and then repeat the whole process, right? And it's the same cycle of events when we do machine learning analysis. And then the question is, how do we define the problem? And there are some good problems and hard problems for machine learning. And could someone describe what should we think about when we decide on a problem for machine learning? Okay, let me start first. The first thing we need to understand, what is the problem? For example, if I do a research on some human cells and I want to understand how can we define the healthy cell from the starved cell, for example. So my problem is I want to classify cells according to two types, for example, yeah? And then I ask, would it be a good problem for machine learning? Yeah, so first of all, we need to understand what is the problem I want to solve. If it's a smart reply, we know that we want to machine to recognize the meaning of the message, and then after recognizing the meaning, to answer this message, to prepare some examples of the reply. Yes, or for example, for Google Photos, we want to classify photos according to person, for example, or some subject. Maybe you know that in Google Photos, your photos are classified. Like, what did you took a photo of? Yeah. Then after you define the problem, what else you need to keep in mind? I want to give you a hint that the main thing, the main message is written in these purple boxes here.
Yeah. As you already told, yeah, it's, oh, sorry.
Yeah, please proceed. Anyone wants to add? Once we know the problem, what's next?
Sorry, I was interrupted. Yeah, once we know the problem and we need to gather as much as more data as possible, but it's also said we don't need to rely, like, to give too much responsibility to a model, because model can predict, but we also need, like, to clarify the instructions for the model. And after that, yeah, also it's not only predictions, but also decisions. We need to think about the good structure in order not from predictions to do later decisions. Yeah.
Yeah, great. Thank you. And also we need to think about how can we solve this problem. So we should have in mind some ways that we want to check. Yeah. In terms of machine learning problems, it is what type of model do you want to use, for example? And it's not that you know exactly that this model will work. We should go back to the ML mindset and understand that once we check the one model and obtain the results, and after the analysis, we can decide to proceed to the next experiment and try another model. Yeah, so this is what this material was about. And the last one is about the hard ML problems. So here are listed common 4 problems. And does anyone wants to share with everybody what are the problems? Or if you didn't read it, just knowing the name of the problem, what would you think? What can be a problem? Anomaly detection, causation, and no existing data. Don't be afraid to just share your opinion, any ideas, casually. Tomoki, I think you have some experience in machine learning. Maybe, do you know any problems that machine learning has?
Yes, I sometimes use machine learning. I had experience. My research is about science, astronomy. So causality is very important. So I always think that machine learning application for machine learning to our problem is very super challenging things. Yeah, I think.
Yeah. Thank you. Yeah, that's right. So we can understand that there may be some correlation, the relationship between things, but we don't know what really caused this relationship, right? Thank you, Tomoki. Abdullah,
yes,
thank you. Abdullah, do you have any idea, like, what are other 3 problems machine learning has?
Okay, actually, I don't have any experience, but I've tried to use a machine learning program to build a model for. I've tried a machine learning program to build a model for identifying some mice behavior, but I try to train a model, but it's actually a supervised learning. But I think sometimes it's hard to label the data because you don't have a clear definition.
Yeah.
And that makes the model also not good.
Yeah, thank you. Yeah, for example, clustering is unsupervised machine learning model. And when the model clusters or groups your data according to different types, it's actually difficult to say sometimes what the group represents, because you don't know what features did the algorithm use to group this data set, right? And they suggest to label some of the data, and this makes it like this helps to propagate these labels into groups, then you have some hints what this group represents. Yeah, but we will learn clustering later on in more detail. And the other two is anomaly detection. So I don't have the good knowledge about this myself, but as I understand, it's difficult to define the anomaly and to put the data, like the description of anomaly, to the computer. So I think this is not, this is what is not solved yet. And the other thing is data. So we need data to work on. And if there is no data, then you can't use machine learning problem. And they also mentioned that to use machine learning, you need large amount of data. If you don't have, then it's better to use some statistical analysis only without machine learning. And we have, I think, 4 minutes only. I think when we had this intro session first time, this is what I introduced you before. And I asked you to think about the problem that you would try to solve yourself. I think it's a good place to start our course, our study jams, because if you have a problem in mind, then you have a purpose to learn machine learning. Yes. So I think it would be good for you to complete this on your own, just to think about the problems, what data would you use, what like metrics would you use, and how. So this helps you to think about problems, diverse problems, and how to formulate question. What machine learning model could you use? And then you can, with a possible machine learning model in mind, we can then proceed to learn models and then apply our knowledge. And if you have any suggestion how to do these study jams in near future, I'm open to hear it for the next 2 minutes or anytime. No suggestion? Okay, so, and just wanted to say that next week, so this was the one of the prerequisites to start the crash course, and the other two are the NumPy. Maybe you've heard about it. Oh, sorry. I should go back to the crash course. And the other is the NumPy tutorial and Pandas tutorial. So next Friday, we will tackle this tutorial. And then next week, we will do the Pandas tutorial. So this is it for today. Thank you for coming. I hope we can proceed learning together next sessions.
Thank you. Thank you very much.
Thank you.
Thank you.
Very
Bye-bye.
much.
Bye.
Bye.